I'm a software engineer by daytime. I'm doing electronics engineering after work hours. I have been coding with PHP for over 15 years. I started with PHP 3, switched to PHP 4, 5, and so on. That's my social networks, hashtag, usernames. If someone wants to follow me or something, I'm available almost on all the networks. Okay, so how to supercharge your PHP web API. Basically, how to make your existing application run faster without sacrificing resources or buying servers and this kind of stuff. So my talk will be about how to make this existing project easiest way to upgrade to run it faster. So I have been experimenting with PHP for performance for over 6 years. Before Composer was released in PHP World, I was working with Ruby on Rails, and I've been experimenting with performance Ruby side, like working with a unicorn server and this kind of stuff. So I was like trying to experiment several things in PHP. But at PHP 5, things was not impossible to make, so I kind of like get into it, get out of it, trying to make some stuff. So how to supercharge your PHP web API? Simple thing, many people told me about 6 years ago, don't use PHP, use some other languages. And I was like, I didn't came someone to tell me not to use it. I came to ask what we can do to make it better. So, like I was saying, I'm just joking. We all learned PHP, we came here for PHP. I'm doing it for 16 years. It means something good about it, you can still working with. Even I know many more languages in the meantime and still use it for many things. So, how to make PHP go fast? That's a really simple question. Many people probably don't even think about it because looking at the current ecosystem of PHP, there are so many frameworks, Laravel, Symfony, which works out of the box. No one's kind of like investigating more in deep side what we can do with PHP to make it better. So let's talk about high performance. And let's talk about how typically PHP is served. So probably the most typical typical setup of PHP servers is usually Apache, mod PHP, FPM, CGI, if someone still uses CGI, these kind of things. Next probably is kind of catching up now these days compared to Apache is Nginx and FPM. It's probably the most common used in many projects because of performance. Then we have PHP CGI. If someone remembers CGI, there's many small projects that still implement CGI and PHP is kind of interconnected with it. And people still use it these days, so it's kind of strange. And probably the most common use in development is internal PHP server, which probably everyone uses, which uses like Symfony, Laravel, everyone uses server run or something similar, which spawns this command, which basically is an internal PHP server, which is works. It just works, everyone uses it, and no one kind of cares on development locally. So how PHP serves request? So we start with a HTTP server getting the request from browser or whatever, and for example, FPM, Nginx, or Apache, or PHP, or FPM starts a script. So basically initializes a whole PHP engine. So what it means is like loading library, calling your whole source, your index PHP source code. So your script receives a call from engine with get parameters, post server request filled up with your current request information, and your script calculates something to do with it and sends it back to the server. The renders response to output. Your server sends Nginx Apache receives the response, sends to the user, script stops, basically kills, and the cycle starts again from scratch. So it means your whole application which was loaded your whole vendor package, frameworks, kernels, everything was loaded now, gets recycled and starts from scratch again next time you start your request. Which looks like nothing, but in reality is almost 80% of your request time is just loading everything and initializing all the kernels and stuff. So let's make it better. So what we can do to make it faster and better to solve this issue, because for example, I have some example projects, production projects which are running FVM and was running 10 millisecond response time, and the whole script after initialization takes 0.1 millisecond to execute, and everything else was just loading all the kernels, all the packages and stuff. So how can we make it faster? Welcome to the experimental world. It's things like if you go to IRC channel of PHP and ask how can make this thing, and most people shoo you away because we don't acknowledge this kind of things happening in PHP. Like Erasmus, the big creator of PHP, was talking in one talk, said, I had to adopt the people using PHP differently, but I was intending to use it. So I had to change my whole thinking about PHP as a language, because I created myself as a template engine for PHP, for C languages. And now people use it for bankings, for websites, and 70% of internet is powered by it. So he was really amazed that people create many ways to use PHP. So this is basically a current situation as far most popular packages, frameworks, tools, and libraries which are used in an experimental way. So we have React PHP, MQP, PHP, we have Truster, which was created by me for one project, which is all these three things are asynchronous, event-driven PHP library, which provides you a way to work with non-blocking inputs outputs. Then we have this fully, if I pronounce correctly, it's a PHP extension created by Chinese developers, used by the biggest websites in China, which provides everything and anything. So it's kind of like a universal tool. Then we have Roadrunner, which is a Golang application made for high-performance PHP applications, server, load balancer, process manager within Golang. So I will only gonna talk about React PHP in this talk, because there's way too many asynchronous frameworks, and React PHP is probably the most popular right now. And asynchronous PHP is kind of a similar thing as you think about Node.js, because Node.js is mostly asynchronous functions and happening, and it uses internally event loop, which, for example, if you create a HTTP server like client and you request information from server, you have to wait for that request to come back to get a response, so your whole application is blocked and waiting for a response. So if you use event loop, you can tell operating system that I have a stream connected to a socket, I'm waiting for data, can you notify me when there is data available, so that I have to be blocked and I can do all things in the same time. So, asynchronous PHP. This is basically a hello world example of using React PHP to create a HTTP server, which is really simple. We create an event loop, which if you have extension available in your PHP system, you can use extensions. There's event loop, there's EV, there's libuv, which is the same as Node.js uses internally. Then we create a HTTP server, we create a function which will handle your requests. So when you finish requesting, just create a response, you set a response, return it to your server, sends the response back to the client. It works. So that's like a typical way. The only thing is differently is that everything happens inside that callback function. After you execute loop run, you have no script. Say typical behavior of PHP, but script goes from top to the bottom. So every time something happens, you get called, and you call back, you return the response, and stuff. So that's like one of the things what synchronous PHP has. So React PHP is typically a low-level library for event-driven programming. Like I said, event loop. provides low-level utilities like routing streams, abstractions, using DNS servers, which is majority of the time we have our systems. When, for example, calling some API, majority of the time your request takes to get API address of server where you need to connect. Network clients, servers, HTTP clients, HTTP servers, components. For example, Guzzle uses PHP internal stuff for asynchronous request times. The whole asynchronous PHP programming is pretty similar how you code in Node.js. You can basically achieve the same thing as if you would spend some time, you can transcompile JavaScript code to PHP. So, for asynchronous programming process, everything is happening in a non-blocking way. So, if you develop your application in a way that you, say, use all the features of asynchronous linearity in your code, then it's really fast and concurrent and really nice thing to do, but it has no blocking I/O, it can run a single thread, it can span multiple things, combine them together. There's many ways to do it. It's really, let's say, advanced level programming. So, what's the cost on using asynchronous things? So, the best worst thing about asynchronous coding is doing heavy computation functions, a task or something, because the time you spend doing something, calculating, which blocks your CPU, you're basically stopping the whole server from doing anything else in the meantime, so the whole concurrency disappears. For example, in Node.js and PHP and our language uses asynchronously, it's really bad situation with relationship database, because relationship database uses transactions, which basically stops everything from doing anything until your query finishes or like something like that, which is kind of really bad when you have way to access database whenever you want, so it's kind of difficult. Requires specific, like I told, requires a lot of specific programming skills, like you can't use your typical frameworks like Symfony, Laravel, out of the box to make it work. It's really hard to debug because if you use PHP extensions for that stuff, majority of the time your debugger will don't know what to do, so you're just gonna say, I don't know what to do, where to stop now, so it's really hard to find some things. So the next tool is Zulu. This is coming from coroutine style concurrency models. So it's basically a PHP extension. It provides event-driven asynchronous code, coroutines, all those kind of things from multiple languages to PHP. Has a lot of libraries. Everything is made up for like asynchronous TCP, UDP, HTTP1, HTTP2, client servers, WebSockets, servers if you run whatever you want. It has integrated process manager. Can handle up to 100 of the million concurrent connections at the same time. So that's how the code looks like. It's a typical HTTP server. Also like Hello World example. It's pretty simple, nothing magical. Just also like event-driven stuff. Looks nice, but like you execute it, it looks really nice. Not just like one single process. So pros of it is simple interface, super fast, provides background task managers, workers. You can basically, while you're doing some kind of like HTTP serving stuff, you can call a worker in the background to do some computation, for example. Your user registration finished, you send user registered, then inside your controller you call a worker and say, oh, okay, now send the email to the user in the background so I can finish this request without blocking user waiting for my request to finish. Used by a lot of big companies in China, Alibaba, but like the majority of the companies use PHP, uses it. The problem with it is under it has so many libraries, so many functionality, it's just really big, and documentation is really lacking information about it, and if you want to develop it and, let's say, use all the features of it, you have to dive into the source code of the extension, try to figure out parameters for the types of things. It modifies a lot of internal PHP stuff, so everything is supposed to sockets, streams, database connections gets modified by it. if you don't know these kind of things and you're just beginning to use it, if you sometimes expect typical behavior of PHP and it doesn't behave like that, it's really hard to figure out if you don't start looking into it. It's hard to debug again, because the problem with it is that simple example I showed you before, when you start a script, it spawns all those PHP processes, childs and managers and stuff, and for example, if you do word dump in your code, you're not going to see anywhere, because it's hidden by these 3 layers of process managers around, and it's, even if you manage to make somehow to output to a console and pass it through, it's really hard. So if you don't know this kind of internal things, it's really hard to do. Also, it's an extension, so it requires you to modify your server, install this extension. Some companies don't like using foreign extensions. For example, the finance industry, we don't like doing stuff. And also, it's made in China, so if you, from Western world, things made in China, it's really skeptical for developers. Like, I have a friend who tried to implement a company, and the managers here with this Chinese-made extension said, no, we don't use this kind of things. And he's like, if open-minded companies realize you can do a lot of crazy things with it, but if it's like old school, leading newspapers, things, companies, it's really hard to say, oh, this is okay, this is open source, we can check inside what's happening, so that's it. So is there anything better than these 2 different things, which looks really difficult and requires less integrity, because less integration to your code? Like I said, I want my existing application to run faster without doing any kind of major refactoring in the code. So let's meet Roadrunner. It's a Golang tool which I mentioned before, which kinda teaches all this asynchronously, coroutines everything, and implements really simple paradigm which was used back in the day, was forgotten. It's the same style as PHP used in the first before Nginx, and PHP was a GUI interface. So basically, it's a Golang starts HTTP server with load balancing and everything, and then it spawns your number, your workers, and your PHP runs on like a just simple script which gets information through SDN from Golang. It contains request information, what's had to be in, and the application, whatever you're doing, calculates response, and just outputs everything back to console, and Golang captures this and sends response back to the user, to the server, and back to client in browser. So it doesn't involve any asynchronous thinking, coroutines, nothing. Basically, you can write any PHP application which works right now with this while loop, convert PHP request, for example, the Symfony request on Laravel, on frameworks like PHP. They have even extensions that are written for most popular frameworks, and it works out of the box. This is just like typical Hello World example how to run it. Configuration is really simple. It has a YAML file in your project, which you define your workers, define your script you want to run, server parameters, kind of things. So like I mentioned, this kind of part. The only difference between CGI and Roadrunner is that your script don't die after request, because CGI typically executes script on shell, calculates response, return to you, and closes. So the whole thing is basically replaced by continuous loop, waiting to get response, calculate, send back. Also, it has a lot of limitations. For example, like limit how many memory you can use. For example, if your worker consumes over 100 megabytes of memory, it kills it and starts a new one. So to keep it running memory full, because PHP is still really memory leaking everywhere. So it's really hard to create a service which runs long term. It's production ready. I have my own several projects that previous companies using still to this day. The company is using big names. The creators of it is a really big company which integrates Golang and PHP using a Golang RPC connections, and it's basically kind of like a child of this development they had. And like I said, it works out of the box, not modifying anything basically to a code. So, like I said, the process is super easy to integrate. Single YAML file configuration. It has really nice combined logging, so it collects information from your loggers and it can output to a single file, so you don't have to use some strange logging repeaters and stuff. No extensions required. just when you install a script, you just call a command line to download binary file, which is called a compile file. It places in your folder and you just can call it and it works. The only con of it is that it requires, because it's constantly running code, it requires you to reload it. But that thing is really modular, and there's already extension module created for hotfix reloading. So basically, you need to monitor your files and change it. If something changes, it restarts the workers. So you don't even feel it in developing in the local environment, and it just runs perfectly fine. So I will show you some light codings, like benchmarks and stuff. I have set up 2 DigitalOcean instances in the cloud, so I can run benchmarks on a single machine and on servers and in another machine. Okay, let me do some more stuff. Just keep walking. No. Oh yeah, it works. You can't see. Still using Niekis also, resolution at the end. Okay. So oh boy. Still visible, okay. So I have simple empty project with a few endpoints. One is fetching data from database. So I create a simple example. I have a currency, just name and ID, a code. I have a controller, which has 2 calls. One is list information from repository, fetch data from database, and render output, typically here for multiple agents. And another endpoint is my simulation of accessing external API to get currency exchange rates for currencies. Problem was that the current service which I used has the limitation for free time. It was only 1,000 requests per month. And after trying this morning to run benchmarks, I killed all my usage. So this time I just created a single file, static response, put it in GitHub. It's supposed to be similar experience to external APIs. So the same thing as code, client, guzzle client, get URL, get information to code JSON, and just output as like a typical application do. So this is like a clean project, nothing spectacular. So I have, okay, let's run that. So I have installed server, I have a VM running. Yeah, so I have PHP running. This is server 6 processors because that was maximum allowed to me register a new account because my account was blocked. So because sudden change of location from London to Japan was too much for DigitalOcean, so they just blocked me completely. And support is leaking, so I had to create a new account. The maximum was allowed me was 6 instances, 6 core instances, so that's supposed to be do now. So we're running MySQL, we're running PHP PM and Nginx, and I'll show you. So this is my list. Why did you work? Always happens when you try and do live coding, something doesn't work. Oh, right. I'm trying to access that server. So this is a PM response, nicely, code works. So this is the list from database. And this is response from API. 2 endpoints, typical application, most has something similar APIs. So we're gonna run benchmark. This is a separate server on the same region, so it's supposed to be better than doing benchmarks from here to the nearest region was DigitalOcean has Singapore only, so it's like half a second delay. So okay, so concurrency, 10,000 requests to a typical VM instance. We have 858 requests per second, with average time 46 milliseconds. Response time, pretty typical application, no optimizations, no caching, nothing. It's like typical stuff which happens. So now let's try to do this in React PHP. I'm gonna do pretty much for a blank project, the same logic as this one, just generally whereas I'm gonna use PHP Process Manager, which is a tool which lets you, which wraps your framework like Symfony, Laravel, or KPHP, whatever, wraps it around and provides you a way to make it run more and more quicker, because PHP is single thread like I said before, and if you have performance, you have to run multiple instances and use it while balancing it, so it can, say, behave faster. So the whole difference for installing and stuff was just a single package. So it's just require PHP VM, PHP PM, and we have this small JavaScript. So I was saying PPM start, like the user Symfony, environment production, logging disabled, removing disabled, defining 20 workers, we're listening on this port, and it looks, let's first stop the still doesn't affect our performance. Oh, this is running PHP 7.4. I'm using this 7.4 since May, I think so, and I had no issues. There's some bugs internal, but they're super specific and single development beta are gonna procure probably, so it works perfectly fine. So, okay, stopped everything. So yeah, so it's exactly the same project. I'm gonna call Start.sh. It starts with nice process manager. It starts with the workers using strip select loop, tells basic information, and now I'm gonna spawn the tab so I can compare. So I'm just accessing that created PHP server and running benchmarks on it. So we're gonna see some drastic changes compared to the previous version. So we had 1.6 thousand requests per second just by wrapping the whole application in the React Process Manager, which runs the same thing as a PM with workers, but instead of killing your request, your PHP code every time you finish a request, to still keep it and just call your function as your request is just a single function call. It's nice, it kind of works like the various issues with memory links, but various protection I was mentioned before happens in managers. I mean, literally, you can define how many requests you want one worker to handle before it gets killed, or how much memory it can consume. So this is just basic implementation. There's like I said before, asynchronous PHP requires a lot of development if you want to make it run faster than typical stuff, because now we just benefit from factor, but we don't reload the code every time we run a request. I will try to see if we have some time afterwards. I will show a bit more hands-on coding on synchronous PHP, implementing this whole API coding without blocking, and see the difference. Okay, so this was, oh wait, we forgot one benchmark was where it's so it was 1.6 thousand on the database call. Now let's call it which calls external API and see what's the difference. Because like I functions fully modifies internal PHP code, which modifies the functions to run faster. So you can see it changes even in the simple call which uses a console internally. If it works correctly. Okay, finished, and we have 377 requests per second available. That's using React PHP. Okay, so now down so we can compare it all. Because I was planning to do this like coding, so we get I still have old MacBook Pro Retina 2012, which works perfectly fine, but its battery dies. Let's go down to school there. Let's again stop. You see process manager spot ends and like, oh, you see that like process manager was killing workers because we reached maximum requests we can handle before we are supposed to be killed. So just managing the memories, keeping sure that everything is running fine and it's like no issue detected. So okay, so now what is also for typical frameworks now we have almost a simple integration for this. I used our integration, which is another simple package. Yeah, this one. The single package installed in the project. Enable bundle. Configure the settings. So I said, like I remember I said like Portfolio has a lot of internal things which are really complicated if you don't know what's happening. For example, it took me a while to understand what is a reactor inside it. Apparently it's like a manager for a group of workers or something like that. But just like not directly manager of everything, but just like some kind of group, and it's technically by documents in Chinese, which I translate to Google said you have to set the number of your processor cores. And the worker count is supposed to be from 1 to 4 times your core, so and it's the same thing, so that's supposed to just like typical default application configuration, and this gets installed using Symfony Flex configuration, so like you just install a package and then it gets installed automatically, so like one-line code installation. Again, it doesn't use everything what PHP's extension can provide because it's way complicated, and for some projects you need to modify everything. Like I was trying to make examples to use real asynchronous calls, but the extensions libraries which are available online were only working with Symfony 3.1 or something, and a lot of changes happened. This is Symfony 5, so I was not able to make it work for this conference. So okay, so now this package is really easy to work with because we just configure them. Oops. Now it's running. So it says running production mode, 24 workers, 6 count, and 28 megabytes of memory for single worker. Constants and mark is killed, replaced. So now let's run some benchmarks. So the same API list. So we have 2,110 requests per second. We're just implementing simple change, which is like 1,300 more requests per second, just out of the box, without doing nothing much. Mean time of all request time was 18 milliseconds. So a simple thing, probably just was limited by MySQL without enabling any caching, because I just had 2 workers from MySQL, so it was dying probably from all this requests from information. But if you implement some like simple caching array, you can probably reduce to like 3-5 milliseconds, maybe less if you optimize your code more. But for a single line change installation to get this kind of improvement, it's like crazy. Okay, so let's save this information. More difficult, but remember that it's a bit different because it's more device internals. So by documentation, August was supposed to work even faster than before because it does really heavy replacements of internal functionality of PHP itself, which is kind of nice and kind of not, because like if you want to use your original function, you can't call them because we are overwritten. Okay, so we got. Okay, I see 3,700 something, so it wasn't much improvement, probably because the thread connection is even less than PHP. Okay, that's interesting. Okay, now we're gonna show you the most simplest integration, which is runner. Use the same first application I showed you beginning, which is supposed to be pretty clean. Only difference is that I have a script which basically initializes a simple application, same as index.php. Does all the typical Symfony things. It creates a kernel, and here's the difference only that it creates communication between PHP and Golang. For addition factory, for accepting PCR server requests in Symfony. Same while loop. I create request from PCR 7, kernel handles it. You create response, terminate, boot your kernel, typical simple application. So let's run it. Only thing that also changed. I'll show you one thing, like how big the difference is. So like I said, after installing that communication component, we have a simple call to binary. Replace it. It downloads binary for Linux, places it in your root object, in your root of your project. We have an error, which is literally a whole server of 70 megabytes. Run it. It reads our configuration file, which is saying bind me to the 000.337. Convert this PHP to a whatever proc you have, 20 of them. Yeah, also studies static folder open, so everything is in the folder was served as normal static resources. And let's go to the server. It runs. So if you, for example, connect to the server. It's 20 scripts are running in the background, waiting for information from Golang. And now we can run the benchmark. Because there's literally no like installation, I think it's just like one package difference. From my perspective, there's only one of the tools which now literally production ready and use by myself, by my colleagues, by my friends, and different companies. And it works really well. So we have oh, let's try again. Something or something. Okay, that's interesting. Somehow it runs slower. But yeah. It feels slower. Just something. Oh, wait. Oh, right. I changed the code back to prose. So this is what we get from performance when we have kernel termination or kernel reboot, which basically tells us every kernel to close everything what we have now, to clear all the memories we have, all the tools, everything was loaded, gets destroyed, and next time you call handle, you basically call all the bundles again, all the configuration files right from scratch again, and this is like directing, you can see impact every time your application has just to read, just to start with kernel. And now I'm gonna disable it, because it doesn't really matter for us, because we just do some simple things and comment out. So it means that the kernel will stay always initialized. Nothing is terminated after request. Working server. And now we run again. You see yes, the difference. Okay, so we had 1,680 requests, which I approach to run next time because it's first time each worker has to initialize this kernel, so it's slowed down a bit. Yeah, 2,200 requests per second by simply implementing few code changes to your project. And if you calculate, if you have like 100 servers, from my personal experience, I have also worked in travel industry before, and we had one project which was running 12 dedicated servers, like full non-specialized servers, it was like 24 cores each, 256 gigabytes of RAM and stuff. After moving code to this kind of like concurrency model, and with a PM, I'm just putting engineers in front of it, so it doesn't get destroyed because these tools can't handle, say, we don't have a queue for requests, so we let the system handle it, and the system kernel is usually not really doing well with handling waiting connections. So tools like Nginx, all the load balancers have this internal way to tell the client that you're in the queue now, wait a little bit, you're processing and you want to enter your queue and comes at your time. So to keep this now minus run rates. That's much slower. Probably GitHub doesn't like me request 1,000 times the same cache file without using the tags. Also, one thing like doing this kind of external APIs is that when you work from Europe and try to access Japanese servers, like I'm trying because I'm probably gonna move to Japan soon, and I'm just trying to scrape information from Japanese websites, and I have like a constant 1.8 second delay without anything, so sometimes it's really fun because the server gets timed out before you start the server request because it takes so long. So okay, we have 399 per second. It's probably the fastest we have right now. So this is basically the numbers. How we have to run directs on FPM. There's no base numbers. So it's let's see how bad it is. It's an average was 380 something. It will take a while. In the meantime, I'm going to show you fast loading. I have 10 minutes left. Let's create a server and create that asynchronous way. See the difference between handling simply and handling with a asynchronous state. How it will behave differently. The nice feature of new PHP Storm is when you copy code and it has some classes and copies namespaces too. The best feature ever. Because when you're copying code around every time you have to go like through 20, if you're working with data objects and you have like 20 or 40 data objects instead of being, yes. Okay, so we have clients in the cross, written JSON. Base PHP FPM is 321 seconds. So as you can see, it's beautiful. So yeah, FPM list 858 plus per second average. Yeah, PHP running on the process manager and the processes and loop and everything. Managed to get 1,600 requests per second. On rate 377. It's probably mostly limited by how external API quickly responds to it. So what I made the biggest numbers, this second biggest number, is 2,100. Just by also implementing simple bundle, PHP is Laravel that has like the same components available, installed into Composer. Symfony is nice because it has Symfony Flex, so it automatically configures most of the configuration. So that's stuff. Roadrunner 2,000. Actually the most easiest way to implement just kind of behave PHP running processes, servers. And here the fastest API calls were Roadrunner. Yeah. We have 199 calls to the API without any asynchronous, nothing for PHP calls, works perfectly fine. Okay, now let's try to run that stuff. Well, this code is available on the GitHub of my profile. If someone needs to run something, I can give you a business card, you can check it later on. Okay. Promise. So when the HTTP call gets finished, call callback, which returns in the meantime a React usually will know that this is blocking, so it's gonna do something else. So it should improve performance of the stuff. yet. Just request per second. Still process. I hate like Mac supports underscore stuff, and Linux is like, nope, that's what happened. Okay. I haven't tried, don't know if it's gonna work. I can still find my errors. Doesn't look like it's gonna work. That's what I was saying about difficult to program, because like it looks okay, no errors thrown, nothing like nothing happening, and it's gonna run like this forever until the browser stops asking because it hasn't received requests. Check this one as well. Now, so that's basically all from the talk. Basic usage of these tools. So, any questions? It's like, who doesn't have questions? Doesn't anyone have anything to ask? If someone wants to talk afterwards, I'm gonna be staying here. I'm gonna be also staying in the social meeting. And if someone wants to meet after even that stuff, I'm gonna leave tomorrow to Kyoto and I'm gonna go back at 15 to Tokyo, so if someone has any questions, you can ask them. Also, you can ask me on Twitter. If someone is, I can give you my business card, you can contact me. I'm kind of like, let's see, one of the implementers of this kind of features in Europe, so I have like a good network of people working together on this kind of features, so if someone's interested in something,
もし日本語で聞いてみたいとかありましたら簡単に翻訳しますんで。
Thank you for your session. And I have a question about the comparison. Do you have any experience about Sword and React PHP comparison?
It's a bit difficult to compare because it's like the example I showed just now, a simple HTTP server is literally what is Track PHP. It's just a single loop, and how you implement it is your own style. I use PHP Process Manager as example because it's the only thing which people now use in production to make it something even comparable to what Sword is doing. Because Sword is doing all these things internally, hidden under these layers of managers and stuff. So if you want, like I wasn't going dive deep into all the features of both features because it's like two different Atlantic, just different oceans. One has like a whole synchronous engine running, you can do many cool things, but all of it requires a lot of specific programming. You can't just bring a Symfony kernel, Symfony project and say it works together. If you want to do this, you have to basically code that from scratch. I have done several APIs using only React PHP, all my process managers, and like getting some millisecond response times from PHP application, which is crazy if you compare it to anything which happens. Like if you know there's a website of benchmarks of like all programming languages and frameworks compared, but most of the good things are not even there because they're not so popular into open source, like used widely to make them available there. But we had run with one user group was benchmarks the same we did it in our feature, our things that you develop is basically second top from the top. Those kind of things, like one of the things is faster is usually C+ or Rust running on Nginx and this kind of stuff. So Zwoola and React PHP is two different, completely different things. Like Zwoola is like to listen like specific knife, it has everything, and React PHP is just a way to bring event loop, like non-blocking behavior to PHP, which you can use without extension. You can use Web extension. It's like many ways to implement this, but like it's like two different worlds basically. And Zwoola is basically more core type based than extension, and it uses I don't know the name of the library under it. It's like one of the bigger concurrency engines in the world basically. So different.
Okay, thank you.
Anything else? 質問とかなんか聞いてみたいこと。じゃあ、この後懇親会とかでちょっといろいろとお話しいただくとして。Thank you for the present. The presentation.
Thank you for attention.